Hey, here we are. It's another week of serverless office hours, and I am sorry to say Julian is not here. It is Eric Johnson this week. Julian, we miss you. Sometimes he lurks. He tells me he can't do it, and then he lurks to make sure I do it right. But anyway, I want to take a real quick minute and first of all say welcome to our two very special guests, two experts in the world that we're going to be talking about today, and so. Real quick, I want to have you all introduce yourselves, and then I'll kick us off here. So, Kim, let's start with you.
Sure. Hey, everybody. I'm Kim Wendt. I'm a senior solutions architect at AWS. I've been a software developer in a previous life, but now I feel like that life has kind of come about with the advent of all of these awesome tools that can help everybody be a developer. So I find I'm doing a lot more of that these days in addition to my quote unquote architecting day job.
Yeah. All right. And Brian.
Yeah. Thanks for having me, Eric. I'm Brian Zambrano. I've been here before. Always a fan. Whenever I get to hang out with Eric and Kim, it's a good day. So I was looking forward to this. But yeah, I am, like Kim, come from a software development, software engineering, architecture background. I came to AWS as an SDE and then moved over to a solutions architect. So I was a specialist solutions architect for serverless and event-driven architectures for a couple years. And right now I sit in our GenAI Innovation Center team. And what we do is build GenAI solutions for customers. And it happens to be for free. So it's a pretty fun place to be, learn lots, and yeah, still having a good time here.
That's such a cool name too. Not the Brian Zambrano. That also is cool, by the way. But like your title and where you work, that's really cool. I'm DevX, DevRel.
Yeah.
Yeah, mine's cool too. So okay. So this topic that we're going to be talking about today is probably, I can't move around so much. Apparently I'm having a problem with my mic. So y'all let me know if I'm messing up my mic here. But the topic we're going to talk about today is one that's very near and dear to my heart and something that kind of got me into this world a little bit. And it's answering the question, does it scale? Right? I mean, this is a question, and we were talking before the show. It's really interesting. Nowadays, that question, that used to be like one of the number one questions you would get. I would sit with customers in my world before I even came to AWS. I was a solutions architect, and you would sit in this room and you would present, and it's going to do this and this and that, and you'd show them, what do you think? And one of the first, and never failed. There's like a principal engineer in the back go, okay, but will it scale? And you're like, I hope so, and so you got into this was really important. I mean, would you all agree that was like one of the primary questions people asked us? Yeah,
100%.
But that's gotten overshadowed a little bit now. It's kind of like, well, but the AI and things like this. But my kind of the way I look at this, and I really don't mean this to be a show where I'm going to do all the talking. I am going to shut up in just a second. I'm going to get your opinions on what I'm saying. But my philosophy is, I think sometimes we forget that we build something and then afterwards it's like, no, it doesn't scale. I'm seeing a lot of things like, well, just install this in your local machine, or go buy a Mac Mini to run this, or and stuff like that. Versus, here's how we do it at scale. What are y'all seeing in the wild?
I'll make a comment. I think that's a really good observation. And before this, we were talking just a little bit, and I was saying, even Kim and I came up with we're going to go through a demo app. We built a demo app to demonstrate this, but we approached this with we're going to talk about how to do this at scale. That was the premise from day zero. And in the demo, you'll probably see, like, any engineer out there could probably look at this now and probably build it in an afternoon. But to your point, can they build it in an afternoon to support 10,000, 100,000, a million users?
Right.
Yeah, probably not. And I think, my take on this is that all of these agents are really good at coding, but they mimic the code that they've seen. And we can be frank, there's a lot of bad code out there. And so
I apologize.
Yeah, I've contributed too, Eric. We've all contributed in our own special ways.
Yeah.
And so I still think my personal belief is there still is a place for well-experienced engineers like us and some of our, our listeners also, to come in and tell the agent, this is the direction that you need to go. You can't just go willy-nilly. You can go not create something, but are you just going to click the ship to production button and call it a day? I don't know. I don't think that is where we are right now. And I don't know if we will ever be there, right? Because again, the fundamental way in the way these models work, it's by looking at a large corpus of data. So if that large corpus is really, really high quality and great, sure, they'll do a good job. But if they're not, then how are they gonna know what's good? I don't know. Can't really predict the future.
Yeah, and I agree, and actually I'm going to hold a few things. Kim, I'm gonna go to you next. What do you think? What are you seeing?
Yeah, I definitely +1 on everything Brian just said. I mean, I feel like even when building this app, like a lot of the things that I feel like, the human of me brought into building this app was the perspective that I've had on architecting these solutions, right? So I could, for the majority of this, we used Kiro. I could tell Kiro, when you go to configure this API, you have to account for this request per second.
Yeah.
Like that has to be accounted for.
Yeah.
And, whether or not these tools have that knowledge baked in now or will in the near future, I can't really say, but I find that that's really where that architecting mindset really helps, so that, taking that idea from prototype to production can be done as long as you can guide it a little bit with some of the knowledge that you already have. Or so I think that's definitely still need a lot of human insight for that. And I think that only comes with that experience that, architecting these massive scale systems brings.
Yeah, I wholeheartedly agree. It's really interesting, and there's been a lot of research done, and I'm going to try really hard not for us not to chase this rabbit, but I do want to say this. There's been a lot of research done on should you trust your agent, eyes closed, go straight to production, right? And most developers, a very high percentage, I don't remember the exact number, and I didn't know we were going to talk about this, but it's like 65, 70, 80% of developers are like, no, I don't trust it, but without human intervention, right? Yes, I trust my agent to churn out code and stuff like that. But the interesting thing is, especially when you get into and what we're going to talk about today is distributed applications, right? I'm assuming, and so distributed applications are hard. That's a reality, and a lot of training for people and models are happy path, not edge case, right? And so that's where the architect comes in and goes, have you thought about this and this and this? It's like, no, most people are like, no, I didn't think about it. I didn't before I started doing this job. And how many times in distributed apps have we tried to chase things down? It's like, and the model, the agents obviously help a lot with that. So, okay. So now I'm rambling, but I think it's a really interesting thing on when we're building, how do we build to scale and how do we guide them? And so that's what today's about. And you all have some tips and tricks. Like I said, both of you, Brian, I've had the pleasure of getting to speak with you on this very topic. Not this year, but last year at reInvent. That was a blast. Kim, you're on my list of people I would love to speak with, so we're gonna have to work something out. But I know you're both experts. You've been doing this for a long time. So where do you want to jump in?
I would say, why don't we, Kim, do you want to kick off? We got some slides we can just walk through. I think that will start us off with a little bit of a talking point.
All right, let's bring this up and yeah.
Well, I'll get us going. I mean, this is, and for we're not going to go through this whole thing, but for anyone interested, this talk is on YouTube, so you can go out and watch it. Kim and I, delivered this at reInvent last year. So this is all about building real-time applications at scale. So we'll just get into it, define what a real-time application is, and we'll show a demo too. So, our premise is that, building applications, it's still hard today, right? To build a really high quality application is so hard. Orders of magnitude easier, of course, with GenAI. But now if you add in another requirement, which is building a real-time application, that's even harder, right? The whole request response cycle, well-trodden path. But real-time, frankly, it's still, people don't do that as often. That's harder. So now if you go a step further and say a real-time application for millions of users, that can be very challenging. And that is, now you're the scared cat. Oh my gosh, how am I going to do this? To your point, or our point earlier, an agent's great. It'll really accelerate you, but will it know how to scale to hundreds of thousands, millions of users? Don't know.
Is it? And sorry, I'm going to interrupt, but I'm going to do the whole hour. So yeah, that's what I do. But it's really interesting when you said that, because we do, you ask, if you were just asked the question and stop, like, can you build a real-time app? Most developers, 99% of developers, like, yeah, no problem. WebSockets, I got this. Yeah, we'll do, server-side events. Yeah, I know all the techniques and stuff like that. But then you start adding 4 millions of requests per second. And it's like, oh, well, yeah, because I have a big computer. It's like, no, that's a whole nother ball game, and I think that's what a lot of people don't realize. Is when you're running something like like an Amazon.com or a Netflix or real time, MLB baseball analytics, those kinds of things. How do you do that real time? How do you not have there's a 4-hour processing gap between what you want. Stocks would be another great example. So the scared cat, I'm a dog guy, but we'll take it. I like it. So,
yeah. And then Eric, you called out some examples of what a real-time app is. And I think we have that in a couple of slides, so we can go over those. But yeah, maybe next slide, Kim. And so let's just get into this, and we'll show you what a real-time app is. So if we could switch over to my screen share, I've got a QR code up, and this is where anyone in the audience, we can do this live. We did this live. I think we probably had, I don't know, Kim, 200 people, maybe 150 in the audience. We had a lot of people in the audience during our talk, and we played this, and it worked. Yeah. So go ahead. I'll leave this up for a few seconds, but this is, and if you can't scan it, it's just trivia.brianz, Brian with an I.xyz. The XYZ domains are super cheap. That's why I have that. But if you go there, you can click on the link if you're in your browser. You can scan the QR code on your phone, and it should pop up and say, game is ready to go, waiting for questions. Is that what you're all seeing?
I am seeing waiting for a question. Yes, sir.
Okay, great. So I am going to flip over to the admin page, and we're going to play a trivia game. This is all we're going to have questions all around from reInvent 2025 announcements. Full disclosure, I did not validate any of these answers, so we're just going to cross the fingers that they're correct, and we'll see how it goes.
No, I'm always right. Okay, good.
Okay, so this is the admin page that you're seeing here. This is just restricted to Kim and I. So we've got 10 questions. We're ready to go. Everyone good to go here?
Okay. Yep.
Okay. Start the game. Okay.
All right, here we go.
What cost reduction can Amazon S3 vectors deliver compared to specialized vector databases? All right, we got a few users. You'll see over here we have a leaderboard. We see answers in the right. And I'll just say to everyone listening or watching, as the game is being played, watch the right-hand side. You'll see answers coming in. The leaderboard will update when the question's over. So anyway, the answer is 90%. So that's pretty cool. Let's go to the next question. What new Lambda capability allows functions to preserve progress and suspend?
I know this one.
There we go.
I know this one. I missed the first one. Nailed it. Plus 29, baby.
Woo-hoo.
All right. Yeah, Lambda durable functions. Very cool release. Okay. What new pricing model was announced for AWS databases at reInvent?
Oh, I should know these.
Database savings plan. Yeah.
Oh.
Very, probably go look at that one up. Corey Quinn was really happy with that one. Okay.
And user one through one, they're kicking my tail.
What do Lambda managed instances allow customers to do?
Okay.
All right. Answer is A. You can run Lambda functions on EC2 compute that you own and manage.
All right. Hang on a minute. A couple of turns ago, I got one right. It gave me 29 points. I got this one right. It only gave me one point. So if I could do it on my hand, that's not enough points. What's that all about?
We'll talk about this, but
Okay,
there's a
okay,
scoring
all right.
algorithm, and it takes speed
Okay.
into account.
Okay.
You gotta speed
Oh,
up, man.
oh,
Yeah.
I
Gotta
should
be
have known
quick.
that up front. I would
Yeah.
like to apologize for our viewing audience for us not telling you that up front. All right, go ahead.
So speed and accuracy. There's
Okay, all
two, two metrics there. All right, next question.
Okay.
Here we go. What performance improvements does Graviton 5 deliver over previous M9G instances?
These are hard questions.
Yeah, they are.
Yeah, these ones, frankly, I didn't know. And again, full disclosure, I don't know if that's 100% correct. This was what
We're testing the engine, not the data.
Yeah, there you go.
Let's be very
Okay, next
clear.
one. How many cores does Graviton 5 feature per chip?
I'm
192 is the right answer there. So we still got, over here on the right, as I scroll down, you can again see these answers coming in, which is really cool. It's fun to see other viewers out there playing this game. What new open source MTP server was announced to help generate IAM policies from code? IAM policy autopilots. That one, honestly, I don't recognize the name. We're going to have to go and look that up afterwards.
Exactly.
We got 3 more. How many vectors per index can Amazon S3 vector support at general availability?
Dude, I am
These are
consistently failing. Yeah. I appreciate you doing this in public with me, Brian. This is great. Kim, thank you.
Hey, you didn't have to admit that, Eric. We can't see your screen.
Oh, I got it right.
We don't know what you
okay.
Okay,
I've always
last 2.
been a tell-all kind of person here, so okay.
What does AWS AI Factories allow enterprises to deploy in their own data centers? Fully managed AI infrastructure with Bedrock and SageMaker. That one does ring a bell. I remember that one. Okay, last question. After this, you'll see your final score. Which 3 frontier agents did we release at reInvent?
Got it. 48 points.
Bonus question: if you know that security agent went GA today. Woohoo!
Oh, hey, there you go.
Fun fact.
All right, cool. That's the game.
Right.
Congratulations. So we have, obviously this was anonymized, so you didn't have to log in. So whoever
the top score is probably me.
That's definitely Eric right there. Yeah,
Yeah,
good job, Eric.
Probably.
Good job. We knew you could do it. All right. Well, yeah. Why don't we switch back to the slides? We could just kind of get into this, and let's just talk about how we did this and what this was.
Okay. And real quick, I'll throw this out. So we probably had 20, 30 users maybe in there, but this would have worked at 20, 30,000. I mean, this would the way these are working, and that's really important to understand. Sometimes it's hard to show load, right? Until you get that, but that's the principles that we're going to be talking about here these are how you do it at massive scales. So, all right, that's just my caveat here.
100%. Brian, where do you want me to jump to in the slides? Down through the architecture, or just keep
maybe
going?
Just go forward real quick, because I just want to talk about we can. Yeah, I wanted to touch on what Eric was talking, because he was talking about some examples, and so I think it's important to understand that real time is all over. It's all over. It's all around us right now. And so some of the things that I mentioned during the talk is, we were in Las Vegas, of course. So you're taking Uber rides. So when you Uber or Lyft, you're there on your rideshare app, and you can see where all the cars are, right? You can see what's going on, and those are updating in real time for everybody. And so, or sports scores, right? I mentioned, like, I'm a Denver Nuggets fan, so I like to know what the score is in real time if I'm not watching it. And I think there's 2 dimensions to think about here. The first is getting the information out to me quickly in real time, right? Like if it happens, I want that to be milliseconds or a second or 2, right? I want that to be really fast. So that's one part of it. But then the other thing is broadcasting that out. So, in the case of either of those, sports scores or a ride sharing app, you need to get information out, not just to Brian, but you need to get that out to anyone else who's watching the Nuggets game, or just on the NBA app, or fill in the blank, anyone else who's looking at getting a ride in Las Vegas. So those are there's 2 parts to that, right? It's like just getting it out quickly, but then there's broadcasting it out at scale. And so, yeah, I think we can go through here and talk about how we design this, and where we met those challenges or where we hit those challenges in this app. Yeah, let's just go a little bit. So yeah, how would you build this? And that, maybe on the next slide also, Eric, at the beginning you mentioned, well, WebSockets. You'd reach for WebSockets right away, which most people or many people would. But still, I mean, frankly, one of my knee-jerk reactions is, can I just use polling for this? Right? I mean, everyone has done polling at some point in their careers. And it's not necessarily like the wrong answer, because it will still work. The trade-off here is that I mean, the advantage is it's really, really simple, right? You just keep asking, is it there? Is it there? Is it there? You waste some compute, you waste some, the code is very simple to write, which that simplicity is nice. But then at scale, is this going to be the best way? Because now imagine you have millions of users constantly polling your backend server. That's a lot of wasted compute and probably not the best way to do it. So again, not the wrong way, but for a system where you do want to scale it, I would say this is a wrong way. And so again, of course, the next option is going to be natural, which is bidirectional communication, which is WebSockets. So just like a phone call, you pick up the phone, the connection is established. Now the server can push messages to the client, and then the client can push messages back over to the server on that persistent connection. So much, much more efficient. It's designed for this.
It's interesting, and I will throw this out. We have technologies like SSE, where if you're a very heavy, because it's standard usage, the client talks to the server, right? Client makes a request, or the server responds. That's the answer. That's request response. But then we've got these where, like what you showed today, it's a constant back and forth. It's a chatter. So it's kind of 50-50. I'm answering, I'm getting requests, things like that. But then you have patterns where it's like, look, I'm going to send you maybe one or two things, and you flood me with information. But I need that it's got to be more than request response. And that's where like server-side events come in, where you do that post, and then you get the events, and you can update. The post is just that every once in a while. So it's really interesting. As you were going back, you were talking about that. In the true technical answer to this, it depends. And I really challenge folks to look at, what does your workload look like? Is it a two-way chatty, which this is? This makes total sense. Is it I'm going to send you one or two things, and you send me a bunch of stuff? Oh, then SSE may make more sense. Or is it, request response? So it's really important to evaluate that, because these can be chatty too. So do we need to support WebSockets if we're not having a lot of communication? That's a little off topic, but it's interesting to me to really think. This again goes back to do we just let the model decide, or here's some things to think about? So.
Yep. Yeah, for sure. Yeah, and I think with that, if you think about, in AI land, it's very much, I'm going to send a request, and then it can just stream a bunch of stuff to me. That model makes a lot of sense. But you generally don't sit there and just receive some GenAI response, on some website or on your phone. And so server side sent events makes a lot more sense for any AI workload. Audio is a whole different ballgame, right? In audio, typically you're going to be using WebSockets. Yep.
Or streaming of some sort. Yeah, exactly.
Yep. So, but anyway, going back to this, so WebSockets, and I think that, with our topic of scale, WebSockets are great, but doing WebSockets at scale is the harder part. So again, I think on the next slide, here we go. So you have to manage all these connections, right? Every person who was connected to our game had a unique connection, so that the server could send a message back out to the user preemptively, right? Here's your update. Here's the leaderboard. You got this right. You got this wrong, etc. How do you fan that out? Let's say we had 100,000 users. How do you take one question and broadcast it out to everybody? How do you take one result of an answer, right? Eric sent me an answer. I scored it. I'm going to go and send it back 1 point. How do we do that? And then can we scale this thing, right? How do we, if you're managing this yourself, what's your strategy for scaling this? So there's a lot of things to worry about or to think through when you're dealing with this at scale.
Yeah,
All right, next.
100%.
So there's a question that I'm going to throw in here, and I actually had to do some lookup on it because I don't have the numbers off the top of my head. I wonder if either of you do. Oh, look, it's kind of covered my face. Hey, different bait says, how many clients can poll versus clients that can have a WebSocket connection? Both would have limitations, I would assume. Either of you have any of that off the top of your head?
Yeah, I can tackle at least on the WebSocket side. I mean, with all of these things, it really depends on the technology that you're using. So the technology that we chose to use to support this application is AppSync Events, which is a
Okay.
fully managed pub sub service that provides managed WebSocket infrastructure. And interestingly, it actually does not have an upper limit on the number of connected clients. We'll talk a little bit about the rate of connection and kind of how we solved that. But as far as the number of clients that can be connected at any given time, there's no documented limit for that. Now, on the polling side, if you kind of think about that, also really depends on kind of what your backend infrastructure is that is
Yeah.
handling those polling responses. In theory, you could potentially scale that up as high as you want, but you might be spending a lot of, unused compute infrastructure to
Sure.
support those polling responses. So it really depends, but at least from the AppSync standpoint for AppSync events, there's no upper limit on the connected clients, but we'll talk a bit about the rate of connections, which is an important distinction.
To throw a real fuzzy number out on the polling, if you were to go API gateway, which when we're doing serverless, that tends to be where most of us head. You're looking at out of the box at 10,000 requests per second, right? And so that's and you may look at it and go, oh, 10,000. I mean, 10,000 is a lot, but in the world we're talking about, is that a lot? That's a soft limit, number one. And number two, the way that works is it's a token, and I won't go into the token system right now because it's hard to explain and nobody gets it the first time. It took me like 9 times to get it right, but basically those are refurbished very quick, so you can have thousands upon thousands of requests per second before you have to raise the soft limit. So it's a great question though, because when we think at scale, regardless of the workload, and I know I'm probably a broken record on this, I don't care if you're building an AI or a gaming system. When we think at scale, these are things we need to think about. It's a great question.
Yeah,
Yeah.
for sure.
Well, Kim, do you want to kind of fast forward us and start getting into how we built this thing? I can let
Yeah.
you like drive the slides.
Yeah, absolutely. So I think I'm gonna jump quite a bit ahead and maybe just so I want to touch on what I mentioned that I kind of alluded to with that rate of connections. And this all kind of goes back to like we're thinking about designing this game, like what are the considerations for designing this at scale? And so one of the first things that we thought about was like, okay, let's say our game gets like super popular, everybody wants to play a trivia game.
Which
A lot
is
of
going
people
to
like
happen
trivia. Definitely gonna happen, especially if it's like really, really fun
with
trivia.
the caveat of we don't know if these are right or not. This is a dead ringer
Exactly.
for
Exactly. But this is really critical, right? Like if we have 5 users join at the same time, probably not an issue. But if we have 100,000 users try to join our game all at the same time, that becomes a particular challenge that we need to handle. How do we handle errors if a user can't join a game initially? Should they be, returned a response, or should we try to like retry in the background? How should we associate users to a particular game? You probably noticed that you didn't have to log in. That was very intentional because we wanted it to be frictionless. And then how do we identify users if they're anonymous? So those are some of the considerations that we had when we were thinking through this process. And one of the first things that came up was that essentially that joining process and establishing that WebSocket connection to AppSync events real-time endpoint. So essentially what we wanted to do here is we wanted to be able to take the client. So all of you, when you were playing the game, you were a client in our environment. And we wanted to be able to persist that information of you joining and essentially associate you with a user so that we can identify and carry your score forward as you play. Simple enough. But we get into this challenge, and you might be familiar with it. It is the thundering herd problem. So let's say all of a sudden we have 10,000 of you trying to join our game all at the same time. And that's 10,000 WebSocket connection requests that you are making to the AppSync events real-time endpoint. This is where that limit comes into play, and that is the rate of connection requests. So that limit, it's a soft limit in each supported region that AppSync events is supported. It's 2,000 per second. And so essentially, we have a problem here, right? We have 10,000 of you trying to join our game all at the same time, establishing that connection to our real-time endpoint, and that's going to overwhelm AppSync, and it's going to say, nope, can't do it, can only take 2,000 of you at the same time. And so we're like, okay, this has got to be a really easy problem to solve, right? Like we have solutions to this using something like Amazon API Gateway, which I know Eric's super familiar with, Brian's super familiar with, you all probably are too. It has a really, really cool capability to handle traffic and handle throttling for you. And so we said, okay, well, what if we allowed 2,000 requests to first hit API Gateway to essentially validate that those users can join the game, right? So instead of going directly to AppSync, we're going to send those folks to API Gateway first, essentially allowing us to handle that thundering herd problem. And then for the remainder of those 8,000, we'll kind of transparently to the client send that typical 429 too many request response so that the client can know, okay, I can't connect right now. Let me implement some back off and retry and try again in the next second. And essentially what that allows us to do is create this really kind of slow player entry control process where it's really transparent to the client. They're essentially just seeing that they're waiting to join the game without having to, be presented with error messages and have to worry about like constantly like slamming on the keyboard to retry. So that's essentially how we got our player entry control. So we created this API Gateway endpoint, which had the throttling capabilities built in to essentially validate whether or not users are able to join the game. And we persist that information into DynamoDB that way. And essentially what this allowed us to do, it allowed us to do a couple of different things. So one, it allowed us to having API Gateway in the front allowed us to leverage not just the kind of throttling capabilities, but also caching for read-heavy based operations. So we can validate that a particular game ID exists and not have to constantly go back and forth to check and see if that game ID exists. We have first-class integrations between API Gateway and DynamoDB. So this allowed us to eliminate any compute in the middle.
Oh, you're making me happy, Kim. I love this. Love this. We're going to have to pause and explain that for a minute. In fact, I'm going to stop you for a second. I'm sorry. You've got a good groove going. I like to interrupt grooves here. All right. So first off, tell us what a first-class integration means. What is, I mean, I know what that, they probably know what that means, but what are we talking about here? And why is this such a big deal?
Yeah, totally. So a first-class integration between API Gateway and a service like DynamoDB or another AWS service means that you can essentially take your request payload from API Gateway and map it directly to an AWS API call. So in this case, we're going directly from the API Gateway request immediately to a get item DynamoDB API call. Full stop. We're using the request mapping templates to essentially make that connection easier so the user doesn't have to get the syntax correct for the get item API call. And what that really allows us to do is eliminate any type of compute in the middle. So like typically, right, what a lot of folks do is they have API Gateway, maybe Lambda in the middle, and then DynamoDB or another service downstream. Great, but what if you didn't have the compute in the middle? Like what would like no compute is no extra cost, no cold starts. It's fantastic.
Again, when we're talking about scale, you look at what's a call to Lambda? So no big deal. You've got a very generous free tier, no big deal. But when we're talking about these kind of scales, you're saving, and if all your Lambda function is doing is routing, it's not actually performing business logic, then it's a wasted invocation. And one of the, and this is, if you know me at all, this is one of my favorite patterns. We use a shortener called S12D, and S12D is entirely built like this. And you have some other things that are really get really exciting. Is one, you do validation API gateway. So one, you never even call the DynamoDB if the data is not right. So that's number one. Number two, you're removing the compute. Number three, and this is probably the best of all, you get to work with VTL. And everybody loves VTL. Am I right, Brian? Brian loves VTL.
I absolutely love it. It's great. I would argue it's gotten better. Again, because the coding agent, you don't really have to worry about it as much. At least that's my experience. And also, go ahead, Eric.
No, you're probably gonna say the same thing. So go ahead.
Yeah, I was just gonna say, if we want to take a look at the code, I have the code up that does this.
Yeah.
I don't remember writing this, so I think one of our agents did this.
You might need to blow that up a little bit, bud.
I can make it a little bit. How's that?
Yeah, you can just close if you close the file folder. Or there you go.
All right.
There you go. Sweet.
Yeah, I mean, we did this in CDK, and so this was CDK code over here. And so you can see here, this comment is, it's a get, game ID is in the path of the URL. And so you can see here, it's a new API gateway AWS integration. And so it's the actions get item on DynamoDB. We inject in the table name, which is the table name for this. And there's some other gobbledygook in here, which, frankly, we don't have to understand too much, but game ID is the primary key on that DynamoDB table. And then here's
the access pattern for the DynamoDB. That's basically the access pattern for DynamoDB. So, or gobbledygook, whichever you want to call it. But yeah, I'm just saying. So if you've never seen this, that is kind of like SQL for DynamoDB. You're telling it, this is the key I want you to grab. This is why DynamoDB is so stinking fast, because the way it's designed. So
and even this right here, you could write this code with this query and this game ID in another SDK. It's the same thing, but we're just happen to do it here in CDK. And here is Eric's beloved VTL right here, where this is the response. So you can see what happens is it gets the game ID back, and then if the query was empty, if the game ID was not empty, and we got something back, then the game is true, or the game exists. Otherwise, we say game not found. So in my experience, 95% of people are going to reach for a Lambda function for this and write it in Python or Node and just do this with an S, because they know how to do it, which again, that's a natural thing. But exactly.
Well, and let's be clear. I don't love VTL. I hate VTL with every red hot passion in me. But I had to learn it a long time before the models, right? And I'm not an expert at it, but I quickly, and it's not for the faint of heart. I am not, I don't want somebody going, look, if you don't build a VTL, you're not a real developer. That's not what I'm saying. But what I am saying is, anytime we remove hops and we move routing to the router and not have compute doing routing that we need, you're saving money, you're increasing speed. And the other cool thing is VTL, especially before the models, getting it working was like, just putting your head through a wall. But once it works, it's just bulletproof. It's really amazing, because it's just a templating engine. I would much rather JSONata, to be honest, but that's not what we have in API Gateway, because API Gateway was built pre-JSONata. But yeah, that's my soapbox for the moment. I'll get off. I apologize.
I agree on all fronts, and I was fibbing also. I do not love VTL like Eric. But I would argue, for this type of logic, there's no application logic here. This is just really, does this exist or does it not? It's really simple.
And you're caching this, right?
Correct.
Yep,
we're using API Gateway caching to cache it.
Yep.
So, do it in VTL. It's free. You're getting free compute, right? Even if you did it in a Lambda function and you could do that in 3 lines of code, that's great. But you're still sucking up API, Lambda invocation. So why even do it? So I think
do you have validation on this? Can you show validation? Do you have that on there? If you don't,
validation of what?
Like validation of the request. at the API gateway validation?
Let's see.
Don't worry about it if you don't. I just was curious if we could show that, because let me tell you my point was that even if you don't do the VTL, put validation at API gateway. Use the validation models, because then you don't call if you don't have the right data, why call the integration, right? So
Yep.
I'm just right now I'm just best practice railing here. So
Yep.
I'll be quiet
And
now.
I think I do have that in another spot, not
Okay,
here,
that's fine.
because it's just
Yeah.
taken from the URL. But yeah, in another spot there is validation.
Okay.
All right. Yeah. Well, yeah. I mean, Kim, do you want to switch back to the slides and we can talk about, because that was just getting into the game, right?
Yeah. Yeah, exactly. Let's where do we want to go next? What's the most, maybe talk a little bit about event handlers, just to kind of, we're on the subject of like, reducing as many hops as possible.
Yeah,
So
that'd be
maybe
great.
talk about one of the capabilities of AppSync events, and then I can toss it back over to you, Brian.
All right. So no,
and
you
one thing
didn't even get very far. Before you get back into it, I do want you to take a minute and explain AppSync events. What is it?
Yeah.
And you're going to show some of the features. And if it's better, it's okay to say, "Hey, Eric, let's push that out a little bit." But I want to make sure a lot of people don't know what AppSync is. I think it's one of the most underrated services we have. I use it all the time. So yeah.
Yeah, for sure, for sure. Yeah, I'll do a bit of an overview of it, and we'll kind of
Okay.
talk through some of the capabilities. So the whole idea with AppSync events is it's managed WebSocket infrastructure. So you have your publishers, so the entities that are sending information out, and you have your subscribers. Those are the entities that are interested in the information that you're sending. And in the middle, that's really where the managed WebSocket layer comes into play. So like what does that actually mean, managed WebSocket infrastructure? So you need to have some concept of who those connected subscribers are, and potentially who those publishers of that information are. And so connection management becomes a really, really critical part. And if you've built this before yourself with your own WebSockets, you might have a database somewhere where you're constantly adding and removing subscribers who are interested in particular topics or events. And that's one aspect. But then what happens when you have to publish something out to all of your subscribers, right? So a sports score update or a trivia question, that's message fan out. And that becomes a challenge in and of itself as well. If you have 100,000 connected subscribers, how do you kind of handle all of that fanning out? And so AppSync says, don't worry about it. We'll handle that. We'll handle the connection management, and we'll handle that message fan out for you. And so essentially what you get is an event API that your publishers can send information to, your subscribers can listen for information from, and one of the key kind of components that helps differentiate those different events and messages between your publishers and subscribers are called channel namespaces. Really, really like simple way to think about it is your segmentation of your messages. So in our case, a really good example of that is we have a game namespace. So this is kind of like our highest level of cardinality that helps us break down specific message types. And then we have channel segments that again help us break down specific pieces of information that some publishers might want to send information to and subscribers want to get information about. And then I'll kind of walk through this one just a little bit more too. So again, going back to the trivia game to put it into like really concrete example, when your publishers, so that's you who are playing the game, are answering a question, you are publishing information over in a WebSocket to the answer namespace with a game ID segment that is dynamic, so it's associated to the game that you're currently playing. Then we also have cases where we have publishers on the back end. In this case, it's an AWS Lambda function that is publishing over HTTP instead of a WebSocket to a completely different namespace. Now, why is this important? If you've ever played with Lambda, you know that Lambda environments are not persistent, right? They have a lifespan. And it doesn't make a ton of sense to have an open WebSocket connection from within a Lambda function if you're just going to close it it's just going to close eventually, right? And so with AppSync events, we offer a couple different ways for you to publish based on what makes the most sense. So with Lambda, probably makes sense to use HTTP. Again, don't really need a long-lived connection there. But for the clients that are playing the game, it absolutely makes sense to have that open bidirectional WebSocket so that you can publish and receive information over it. And then on the subscriber side, subscription is always over WebSocket because that's the part that we really need to get that information right away. Can't really do that with HTTP, response streaming aside, but our subscribers can subscribe to those updates and get information about the questions for that particular game ID as it's coming through.
So can I interrupt you for a minute here?
You can. Go for it, Eric.
All right. So we had a great question come in right about what you're talking about. I'm staying on topic for once here. This is a question about AppSync. Can I create an application for WhatsApp to send pictures and process it by an LLM and get responses? Or is it better to do with API Gateway plus Lambda? It seems a good to use this very one. I don't know if one of y'all want to grab it. I certainly have opinions, but I'll be quiet for a minute. Either of you want to grab this?
I can chime in here because I've done this and experimented with them because when GenAI sort of came on the scenes, AppSync events was out there, and that was my natural question to myself. It's like, hey, could we use this for GenAI? So if you break this down, I think there's two parts of it. One part is I want to make an LLM call, so for that you're going to need some runtime, some compute.
Mm-hmm.
I think the two big ones nowadays are, for this, I mean, maybe there's probably three, right? Maybe it's a container, maybe it's Lambda, and now we have Agent Core also. Those are Agent Core runtime. So those are all compute platforms. So what's the best one for this? I don't really know best, right? If you're a container shop, put it in a container. You probably already have the infrastructure and have the plumbing for that. If you're, a Lambda fan and your LLM calls are not going to take too long, I think Lambda is perfectly fine below a certain scale. The thing is that, a Lambda function, you're paying while it's running, even if it's not doing anything, while it's just waiting for that inference to occur. So you're paying for that idle. So if you do this, I think at some, small scale, it's not that big of a deal, right? Lambda is still very, very affordable. If you're doing this at large scale, I would go over to Agent Core for the runtime because that you're going to be paying. It's purpose built for LLMs, right? For AI,
and it's ephemeral as well. It can go up and down as needed. It has a state, but it can go up and down as needed. So,
So I mean, think about that. Is Lambda the best place? And if it works, then great. And so can your Lambda function, let's just say you use it, can your Lambda function run some inference and then send back data over AppSync events? The answer is 100% yes. You can absolutely do that. In fact, I've done that. I've been doing something on the side, and I'm using AppSync events because in my use case, there's a series of things I need to execute that are asynchronous and long-lived. I'm actually running a step function workflow, and at the end of all that, there's a call to Bedrock to do something. Well, I want to stream all of those events out to a front end, so that the front end knows exactly what's going on. And so, like I said, just the last part is the inference. And so you can do all that with AppSync events, is get some events, emit some events, have those shoot out over these channel namespaces so that your client can see like, oh, it's going through the step function workflow. It's at this state, this state, this state. Now it's doing inference. Now I got the final results. Great. Now I'm done. So the answer is yes. I mean, that is a very valid pattern.
Yeah. What's really fun is your agent can call back to your WebSocket through AppSync events as well, so you can send updates as you need. So you just roll into your agent and say, hey, let them know how it's going, that kind of thing. It's a lot of work you do there. Specifically, I want to answer, because you asked about the comparison with API Gateway. Again, it's back to it depends here. AppSync is a full feature. We're going to handle your topics. We're going to handle, as Kim was showing, it's going to manage these for you. And so you get that out of the box. And so that's usually my go-to. When I use WebSocket API, I'm sorry, how you doing, Eric? API, they pay me here to speak at AWS. When I use API Gateway for WebSockets is when, number one, I'm not going to have a lot of topics to manage. It's just going to be one-on-one back and forth. So it's a very quick up and down. It's just boom, there it is. Number two is well, I've lost it. That's pretty much number one. That's when I do it, is when it's just, look, that's all I need. And sometimes we do that. It's like, look, it's just have the user, but you have to manage. Oh, this is the number two. Number two is if I want to custom manage, and we have companies that do this at scale. They're like, we want to handle things a little differently than how AppSync does it. So we're going to manage the topics, and we're going to manage, how the grouping is done. So API Gateway is more for, I'm going to build a full-on WebSocket solution. That's part of what makes me different from everybody else around me. AppSync Events is more for, I need WebSockets in something I'm building, so I'm going to drop it in. So hopefully that helps.
Yeah, and I would give a big shout out to AppSync Events for its ability to broadcast. And that's the thing where, if you're doing this yourself with, API Gateway or self-managed WebSockets, you're going to have to figure out a way to broadcast, right? So here, it's just done, right?
And that usually turns into scanning DynamoDB, and it's just bad practices all the way around. So if you're going to build your own WebSockets, you want to know how to do that, definitely. There's a follow-up here. So I prefer on-demand inference. Yeah, on-demand is where I head most of the time too. I think Brian's use a container. That's a really good one. That's, again, like, and this is something I want to take a moment and say. Agents are just like any other workload. The same things we're thinking about here. Is it going to be long running? Do I know my volume? Those all apply here. I say jaw. It's just another workload. And sometimes, well, it's a workload to beat all workloads. And that's right. I mean, the agents are crazy and they're fun, but we still have to manage that architecture at scale. I mean, that's what we're talking about here. So, so I think the ephemerals are great. Another pattern I would tell you to look at, and I actually this is a shameless plug, I openly admit it, but it's in context, so you guys can't blame me. I just put out several videos on event-driven agents. And so where it's doing deterministic orchestration of non-deterministic agents to have some control and some speed and some order, and it's all done with durable functions. And in the particular example, I'm running a Lambda function. And so in this one, I actually I built an at-scale video monitoring, and I'll throw a link into it in a minute, where it actually evaluates videos and does all this stuff. It's basically like YouTube. If we had to evaluate 1 million videos in a day, we need to automate that. And how would we do that? So there we go. Next, I never have next. Oh, okay, I don't know what they're saying. So okay, so so I'll stop there and give it back to you. I will give you all a heads up. We got about 7 minutes and we have a hard stop, so I'm gonna shut up. So go, Kim, go.
Yeah, awesome. Thanks, Eric. So I'll just maybe double click on one of the things that Brian was talking about, which is the message fan out becomes another kind of scale consideration that we were thinking about, right, when designing this. Like, should we use API Gateway? Should we use managed WebSocket, or sorry, our own kind of WebSocket layer? What really stood out about AppSync Events is that it does all that for you, right? Like, you don't really have to think about how many clients I have connected. Like, just let AppSync kind of handle that fan out for you. And so that really comes into play in the trivia application when we're talking about the questions, right? So Brian showed that admin interface where we're kind of driving that game experience back and forth. We decided here it made sense to use API Gateway in a Lambda function. Again, there's still place for that pattern, and for our admin interface where we needed to do some complex business logic inside of Lambda, made a ton of sense for us to incorporate that. But what really kind of helped us was that scale out to all of our connected clients. So when we trigger that game start and we transition between questions, what's actually happening behind the scenes is that Lambda function is publishing out these question payloads. They're super lightweight, just a JSON object that contains the answer choices and a timestamp, which helps us with scoring later down the line. And essentially, that gets sent out to all of the connected clients that are currently subscribed to that question game ID namespace. We don't have to do any of that ourselves. That just happens seamlessly for us, which is, again, one of the main things that we thought about when it came to scale.
And I'll just summarize this just because I want to hit this point. It's really important. So on our side, all we do is we have the admin interface makes an API gateway call, and it says, go and publish the next question. We go and fetch that from DynamoDB, create this payload that you're seeing, and we make one API call out to question/game ID, right? All of the clients are subscribed to that channel namespace. So they all just, it's the same front end code. They say subscribe, subscribe, subscribe. So N number of users out there are subscribed. So our one call to publish to AppSync events automatically broadcasts out. We do nothing in order for that to work. It just happens magically. And like Kim said earlier, it's going to handle the scale for us.
Yep, exactly. Awesome. I know we only have a couple minutes left, so I think maybe one other thing that we'll talk about, just because it's I feel like it's relevant, right? We're talking a lot about like the backend layer, but Brian, I don't know if
Yeah.
you want to talk a little bit about the kind of application hosting side of this, because that is also a scale component that we need to think about.
Yeah, I'll just mention it real quick because again, Eric mentioned underrated services. So this is another one, which is Amplify hosting. So we had a single page React app up there, and most people, what they're going to do is they're going to reach for an S3 bucket, self-managed CloudFront CDN, wire those together, and now that's how they're going to host their app, which still works, right? Upload your assets, it works. But we also have something called Amplify hosting. And it's not Amplify like the library that people might be familiar with. And again, like with this, there are other components. You need Route 53, maybe you want a WAF, certificates, all those things. So the full picture is, it's not hard. We've done it 1,000 times, but it's just a lot for you to do. I would get this wrong probably a couple times before I got it right. And then there's cache invalidation. So Amplify hosting simplifies. It does all of this for you, and it simplifies the whole thing, and it gives you CI/CD on top of that. So I have this hosted in GitHub. I make a change, I commit the change, Amplify hosting runs the build, deploys it all out for me, does the cache invalidation, and it gives me a certificate and CDN all in one shot. So there's nothing that you need to do really in terms of just a basic app with secured HTTPS endpoint. This is going to do it all for you. So very underrated. Go have a look at it.
If you love SSR, if you're like, look, I'm using Next or React and I do SSR, it'll handle it for you. So
Yep.
I mean, so it's a lot of abstraction, things that you could absolutely build, but it handles it for you. So
exactly.
Okay, let me ask you a question, Kim and Brian. Is this their GitHub link for this code by chance?
This is something that we talked about doing after reInvents, and we have yet to do it. We have the code, but I think we need to go through our internal open source process and get it open sourced. So not yet is the answer.
So so keep an eye out, and we'll push that. Watch the social medias and stuff like that, and we'll push that out. Both of the videos I just posted, which follow a lot of these same principles, those have links to repos. So you can grab the two different videos there. So if that helps. But okay, with that, we are at time. Look, we do this every week. Love the questions. Brian, Kim, thank you so much. I know you all are busy. You're like, I'll just take an hour of my time. I appreciate that you did that. It's more than an hour because you prepare all this. And we love having you both on. Julian will be back next week. And we've got lots of shows lined up. So keep an eye out. And with that, first of all, I'm going to say thanks to Jeff, our producer, who always keeps us up and running and looking nice, so to speak. He can only do so much. And we'll say thank you. See y'all later.
Thanks all. Thanks, Eric.
Thanks, bye.